Okay, we'll start from here. So we have one correction in the last video where we have represented it 40. Instead of that we have 45.95. So please note that it is 45.95, not 40. Now we'll move to the next lecture. So what is the relevance of finding out these coefficients from these the equations that we will discuss today, and we will discuss how we can find out this coefficient by using Python. How we can do that. So basically we have here we have different equations. For example, if you consider the quadratic spline case, for corresponding to a single line, we have different equations, different coefficients. So let's say for example the case of the first spline. For the case of first spline, let's say S1. Okay, so for S1 we'll be having equations. First let's say a1 x0 square plus b1 x0 plus c1, and this is your y0, and then we have a1 x1 square plus b1 x1 plus c1 equal to y1, and this is for first spline. Okay, so let's draw that here. Let's say we have the spline, quadratic spline like this. Okay, so for the first spline S1, and this is S2. So for first spline we have this set of equation. For second spline, then we can write for second spline S2 will be having equations like say a2 times x1 square plus b2 times x2 plus c2 equal to y1, and then a2 times x2 square plus b2 times x2, this is x1, b2 times x2 plus c2 equal to y2. Similarly, if you are having n number of equations you will be having n number of equations for different splines. So, and we also have another equation correspondingly for the different nodes. At nodes we have the condition that d square of s1 by it is not d square, it is dx, so it is only dx. So ds1 by dx will be equal to ds2 by dx at x equal to x1, So correspondingly for different this is for just one first case at x equal to x1, and if you are having n splines, then we will be having n minus 1 number of this kind of equations. So that equation also we have to consider. And third case, we have boundary condition, and correspondingly we will be having equation for example dsn by dx d square xn by dx square will be equal to 0, and this is at x equal to xn. Okay, so this will give you another equation. So all these equations we have to consider, and we have to make it in a matrix form, like this. So your matrix form, and you will be having your variables first. So you will be having your x0 square first, then your x0, then your x c1, like that. So we can write it like x0 first, x0 square, okay, then x0, so you can write the matrix representation of this equation like this. So we will be having first our x matrix, so that is this one, okay. This is our x matrix, and then we have the coefficient matrix, let's say it is C, and then we'll have our y matrix like this. Now what we have to do is that we have to solve this for to get this coefficient matrix. This one we have to find out. So in order to get that, we can write the coefficient matrix C as x inverse y. So if you take matrix multiplication of the inverse of the x and y, then we will get the coefficient matrix, and correspondingly we get a1, b1, c1, all these values. So all these values will get after solving this equation, that x inverse y, that is matrix multiplication. So in order to get this expression, we can use our Python program to, you can use the linear algebra functions. So now you can use these different Python options to solve these equations to find the coefficient matrix. So in order to do that, we can use np.linearalgebra.solve x comma y. So where you have this x matrix and y matrix, and if you give directly this x comma y, then it will be solving for your coefficients by considering these equations, all set of equations as consecutive equations. Now in the other case, we can have expression like np.linearalgebra.inverse of x. So in this case, what we had to do is that first we had to find out what is the inverse of x, okay. Then that inverse of x, suppose this is equal to some d, then we can have d equal to np.linearalgebra.inverse of x, that is your d will be nothing but x inverse now, and then you have to take the dot product of that x inverse or d with y. Then we can have this coefficient matrix C. So in both this way we can find out what is the C, and the importance is that why we need this coefficient. Suppose we are having a spline S1, we already wrote here. So suppose if you are having S1 and S2 here, so for this S1 we have the coefficients correspondingly as a1, b1 and c1, and for this S2 we have coefficients a2, b2 and c2, okay. Now if you want to find out any value in this spline line S1, we have a1 x square plus b1 x plus c1. So if you know what is a1, b1, c1, and then you can find out any point in this spline, quadratic spline S1, for any value of x you can find out what is value of y. That is important. So if you want to find out any point at this point, any point you can find out if you know what is the value of a1, b1, c1. Similarly, if you know the a2, b2, c2 in S2, then we can calculate any point in spline S2. So this is why we had to find out this coefficient, then we can calculate any interpolation data in between these points